In this video, I'm going to talk about absolute and conditional convergence. So let's take a look at the definition and try to sort out what this is talking about. A series, A sub n, exhibits absolute convergence if the absolute value of the series converges. So associate absolute convergence with the absolute value. In other words, if we get rid of the alternating signs, so what we're really doing here, when we take the absolute value of A sub n, in other words, we're taking the absolute value of the sequence part of the series, we take the absolute value of that. In other words, we eliminate the fact that it's alternating between positive and negative. All the terms are positive. So if the series converges when all the terms are positive, then it has what is called absolute convergence, which is implying that the alternating series will also converge. However, a series A sub n exhibits conditional convergence if the alternating series A sub n converges, but the absolute value diverges. So if the absolute value of A sub n diverges, that means when all the terms are positive, it's diverging. Okay, but when the terms are alternating, it's converging. Then it is then it is conditional convergence. So in other words, when all terms are positive, it's diverging, but when you have alternating, it's converging. Okay, this is called conditional convergence. All right. Second little important theorem here is absolute convergence implies convergence. So in other words, if we can show that the absolute value of A sub n converges, in other words, when all the terms are positive, it converges, then the series itself alternating will also converge. That's what absolute convergence implies convergence. All right, so as always, this makes a little bit more sense as we go through and do some problems. And I only have two here. I don't know why my notes are so short on this. If necessary, I can throw in a couple more problems and add them into my notes. So the first thing that we want to do is test the absolute value for absolute convergence. Okay, so here's our series. And so when we test the absolute, so we put the absolute value around that, what we're essentially doing is we're eliminating the alternating part. So we don't need that in there anymore. We just put a 1 in there. So what we're really doing is we are just testing 1 over 3n plus 1 to determine if that converges or diverges. And so we can do that by using the limit comparison test. Yes, we do have to use some of the previous learned tests. So remember, with the limit comparison test, we select a comparison series, which I chose 1 over n, because that looks somewhat similar to 1 over 3n plus 1. And so then what we do is we take the limit of the original series divided by the comparison series. All right, it's always the original series, which in the limit comparison test was, I believe, A sub n, and the comparison series was B sub n. But don't get your A sub n's and B sub n's mixed up. It's just the original over the comparison. Okay, so taking the limit of that, well, this whole thing, this all simplifies to this, and clearly then the limit of that is 1/3. So the limit exists. The limit exists, and the limit is 1/3. The limit comparison test says that if the limit exists, then both the comparison series and the given series diverge or converge. And so we know that 1 over n is a diverging harmonic. That is a diverging harmonic. Okay, a diverging harmonic. So since the comparison series diverges, our given series diverges. So what does this mean? What have we done so far? What we have just shown is that if all of the terms of the series were positive, that the series would diverge. If all of the terms of the series were positive, then the series would diverge. And so that's what we're finding when we do absolute convergence. Okay? We're taking the absolute value of the series, which eliminates the alternating part. It would diverge. All right, so it does not have absolute convergence. But what about conditional convergence? What happens if the terms of the series do alternate? So we do the alternating series test. Okay? And so in the alternating series test, right here, we see that it does converge. Okay, it meets both of these requirements. In other words, number one, we can show that it is a decreasing function. And number two, we can show that the limit does equal 0. So it converges by the alternating series test, but it diverges by absolute convergence. Therefore, we conclude that it is conditionally convergent. Conditionally convergent. In other words, it will converge on the condition that the terms alternate in sign. Okay, the next one. And this next one, I probably need to put a little bit more explanation into this, but so first of all, our function, we see that we have cosine of n in the numerator. Well, that's the part that's making it alternate. Once again, cosine of n alternates between plus and minus 1. So when we do conditional convergence, we do the absolute value of this series. Essentially what we're doing is we're getting rid of the alternating part. And so what we're looking at is we are just looking at whether the series 1 over n squared converges or diverges. Well, that's a converging p-series. That's a converging p-series. So therefore, what we have just shown here, since we know we don't have to actually do anything, we just know that that's a converging p-series. So the absolute value of this series converges. The absolute value of this series converges. In other words, when all the terms of the series are positive, the series will converge. It therefore has absolute convergence. Now, I didn't do the alternating series test. I don't need to, because if we go back to this right here, it basically said absolute convergence implies convergence. So if the absolute value converges, then the series converges. That's all I need to know. So if we show that it does have absolute convergence, which we did, you can stop. That's all you need to do. You don't need to go on to do the alternating series test. All right, that's it for this video. I might throw in another video, do a couple more of these problems, but you're also going to see more of these problems in the next section when we get into the ratio and root tests. We're going to be talking a lot more about absolute convergence. All right,